All right, so yesterday I went through 8.2, I believe. So we need to look at 8.3 today. Oh no, I went through 8.3 yesterday. So I will look at one of the examples on each, and then I expect you to be done 8.3 today. None of you were on here yesterday, or only Rory was on here yesterday. So you need to, even if you're missing the days of the meetings, which is fine, you need to do the assignments that are assigned. We still want to try and get this done and completed. And in order to get it completed, we have to move basically at a section a day. So, okay, so 275. Did any one of you three look at the video from yesterday?
Yeah, I watched the beginning part of it.
You other two, Brandon, Mary?
No one else got a chance.
I did some of 8.2, but not any of 8.3.
Okay, in order for us to get through this course, it's going to be necessary that you got to keep the pace. So if you're missing the class, that's fine, but you got to do it. So we've got a 8.3 is the rules of logarithms. So changing from single logarithms to expanded form and vice versa. So I'll look at page 275. I'll go through example 1b. So right now it's a singular logarithm and we want to expand it. So I've got square root xy cubed base 5. Okay, so the first thing I do.
I can't see anything.
I'm not sure what to tell you. You can't see me or the board?
No.
Can you? Well, you can obviously hear me though, right?
Yeah, maybe I should just try like logging out and logging in again because I could see it at first.
Okay, let's do that. Okay, so the first thing I do is I change the rooted value to an exponent. So I get xy cubed to the 1/2. I move that 1/2 in front. Because it's multiplication, I expand it by adding them. So I've got that. And then I have to move that exponent to the front and multiply it by 1/2. So the expanded form of this is 1/2 log x base 5 plus 3/2 log y base 5. Okay, so if you watch the video from yesterday, I explained why we do this. Okay, so there's doing this, and then there's putting it as a single logarithm so we can switch it to exponential to solve questions. So we want to be able to work back and forth between exponential and logarithm. So that's where we're leading into. Okay, so let's look at working example 2, page 276. And I will go through
Mary's internet isn't working at all.
Okay. Well, hopefully it comes back on. All right, so page 276, I'm going to do working example 2b. So we have to change to a singular logarithm. I got to multiply 4 times 2. That gives me that. This stays as log y to the 6. Subtract. And then I got log y to the 2/3, the base 6. So that's the first thing that I do. And then I'm going to write this out as a single logarithm. So if it's a positive value, if it's a positive log, I put it on top. So I got y to the 8. That's that times y on top. And on the bottom, I have y to the 2/3. So I've got y to the 9 on top over y to the 2/3 on the bottom. I don't really need this line. I'm just going to move this lower. So this becomes log base 6. So y to the 9 divided by y to the 2/3 means I have to subtract the exponents. So that looks like it will be 25 over 3. And I have that as a single logarithm. Okay. Now, the reason that we go from expanded form to a single logarithm is then we can easily change it into exponential. And then we solve for it. So this is to solve for multiple logs where the x value is in the logs. And then we have to change it to exponential to solve the question. You'll see in 8.4 when we get into this. Again, this skill is a lot more imperative to you in this class than it was in the applied class. Okay, the applied class was more about the graphing. This is going to be more about the algebra for it. Okay, and I'll look at example 3A. Or actually, I'll do 3B. I did 3A yesterday. So I've got log of 216 to the base 6 times the 4th root of 36. Okay. So I need to, basically what I'm trying to do is I'm trying to simplify this down. So here's what I do. My focus is always on my base value. So my base value is 6. So I want to change 216 and 36 to a base 6. So that's going to give me 6 to the 3 times 6 squared to the 1/4. Okay, the 4th root becomes 1/4. 36 is 6 squared. So let's keep working with it. 6 cubed times 6 to the 1/2. I add those fractions together. So that is 7 over 2 to the base 6. That goes to the front. So I have 7 over 2 times log 6 to the base 6, which is 7 over 2. Okay. So that's just simplifying and trying to get all the values to the base, so that basically what you're doing is you're using that rule where you got to get the log of a value to the same base so that it equals 1 to simplify your solution. Okay, so that was 8.3, and I went through all of that yesterday. So if you check yesterday's YouTube video, it's all on there. Is there anything in 8.2 that you want to see? I also went other questions in 8.2 that you want done.
Actually, can you go through 3A if that's okay too?
Yeah.
Thanks.
Sure. Okay. So I got the log of x plus 2 subtract 3 Base doesn't really matter, but it is base 2. Okay, so they've got A, B, C, and D still the same as we always do. All right, so my A value, B value, C value, and D value. So A is 1, B is 1, C is -2, D is -3. Okay, so this would be the graph of y equals the log of x to the base 2. Okay, so focusing on my coordinate, okay, 1, 0 is one of my primary coordinates. And I want to find out another, I want to use another coordinate here. So another coordinate I could use is if I put 0 in for x, I get 2. I get the log of 2 to the base 2, which is 1. 1 subtract 3 would be -2. So I have 0 and -2. That's a possibility, okay, for this particular one. But on my original, that doesn't work. So I'm looking at the original here, which is y equals the log of x to the base 2. I'm sorry, that's crammed. So if I put a 2 in there, I get 1. And if I put a 4 in there, I get 2. So those are two other coordinates I can work with. 2 and 1, 4 and 2. So those would be the three coordinates that I would work with from the log of x to the base 2. Now I know that if I put 2 in there, the log of 2 to the base 2 is 1, and the log of 4 to the base 2 is 2. So now where do I move them? Well, I move them all left 2. So I go move this left 2, so that's -1 and 0, 0 and 1, 2 and 2, and then I have to move them all down 3 because of D. So this becomes -1, -3. This becomes 0 and -2. Again, I'm cramming it in here. And that becomes 2 and -1. So I could graph those three coordinates, all right, as they've transformed, just like I've done in the past. Or I can basically look at it and go like this. Let's focus on the asymptote for 1 second, all right? The D doesn't affect the asymptote. The C does. So I've got to move my asymptote over. 1, 2. My new asymptote is right here. Okay? So there's the first key thing. My 1, 0 coordinate becomes -1, -3. So that's down here. 0, -2, right here. 2 and -1, right here. And there's my new graph. Okay? So if I focus on three particular coordinates, I can do the transformations using C and D from the log of x to the base 2, or I can simply just translate my asymptote and my 1 and 0 across, but I do kind of want to get my intercept values. All right, so those are somewhat important to me. Okay, now the one point I'm missing that I should get is this one right here. So to get that, I made y 0, and I got the log of x plus 2, base 2, subtract 3. I add 3. I change to exponential, so that's 2 cubed equals x add 2. That's 8. And then I subtract the 2 equals x. X is equal to 6. So this coordinate right here is 6 and 0. So that's another coordinate that I want. Basically what I want is I want my asymptote drawn in proper. All right. I want my 1, 0 coordinate drawn in correctly. And I want those two intercepts in there as close to as possible. Okay. And actually solving for them. All right. Brandon, you okay?
Yeah, it works. Yeah, it works. Thank you.
Okay, no worries. All right, and I did show B and C on yesterday's video, if you want to look at it.
Yeah, sure. I'll take a look at it.
Okay. Any other questions this morning from 8-2?
I don't have any.
Mary?
Either I'm good.
Okay. All right then. So you've got, you need to get through that 8.2 and then get on to 8.3 at some point today. All right. So I want you to see you get some work done.
It's too nice of to do homework.
Yeah, well, it's not June or May yet, so I would get it done now.
I guess so.
It would be
Do you think
no,
we could be a little bit? Do you think we could be done a little early in this class?
well, at the rate you're going right now, no. You guys have to do the work each day and you're not doing it. Right?
I'd love to be done like a couple of weeks early.
So would I. But it can't happen unless you guys cooperate. Correct?
I guess so.
Yeah. Okay, so anything else with chapter 8? Do you guys want to work for a few minutes or do you want me to go into physics right away? What would you like?
I'm going to physics because David and I have a calculus test at 11:45.
Okay, let's get into physics then. I'm going to shut the stream down.